Hello and welcome to RushDB in Action, building AI native apps with self-aware graphics. Today we have Artemiy, who is going to be the presenter. Over to you.
Hello, my name is Artemiy, and today we'll see how to bring graph data intelligence to any data without excessive preparations and eliminate rudimental data rituals to bring unmatched speed and data observability for dev teams, AI agents, by introducing so-called labeled meta-property graphs with hyperproperties approach, which we are proudly crafting in RushDB. RushDB is an instant graph-native database built on top of Neo4j. It removes the need for schema preparations, ETL, migrations, letting both developers and AI agents go from raw JSON to self-aware graphs instantly. It combines strength of reasoning possibilities of RDFs with LPG simplicity and expressiveness. Let's dive in. We all used to follow some data rituals, right? So let's recap how every product routine looks like. Even in 2025, we're still teaching data where to go instead of asking what it means. Every new feature becomes a mini data engineering project. This is the bottleneck not for devs only, but for agentic systems too. They need connected context, not predefined tables with handpicked and manually created descriptions for each column. The result? Slow iteration, fragile pipelines, and agents that cannot reason over a context they don't see. This is the fundamental bottleneck preventing true agentic intelligence. Let's make some observations. Humans think in relationships, not tables, not documents. In modern software development landscape and startup environment, speed isn't an advantage anymore. It's a life death question. These rituals are our roadblocks, especially when it comes to build in tune with agents, LLMs, and ever-changing market demands. Lots of startups actually died because couldn't perform pivot fast enough. It's surprisingly how little we ask ourselves about how we perceive the world around us. How do we think about things around us and beyond? It turns out we think in graphs. Primarily, we think in graphs. It's because evolutionary process developed us so to think in graphs as the most natural and efficient way of describing everything around. So let's make some experiment. Let's perform some experiments and try to make some observations too. What comes to mind when you think about property like title or color? Let's say title. Music album has title. Museum has title. The dish has it too. We can come to conclusion that in the most industries and most data we work with has likely more values than property keys, even for diverse nature and origin of it. Thanks to relational databases dominance, we have a lot of same-shaped records out there: orders, users, prescriptions, items, etc. And this how hyperproperties get the spotlight. So hyperproperties serve as unique reusable entities that interconnect records based on shared k-type, k-name, and type. While hyperproperties itself links these records, the specific values remain stored within each individual record. Each property name, like name, price, created at, becomes its own node with just metadata and usage and type. It turns the graph into self-describing ontology, enabling analytics, reasoning, and dynamic schema discovery. Let's perform one more experiment. We build our apps using JSON, right? Our apps speaks JSON. Our API uses JSON. Our front end uses JSON. And we even send JSON back to our service. And the most cases for defining normalization boundaries, relationships, and data types, the simple heuristics evaluated over commonly used format is often sufficient. So our desired payloads and responses already contain everything we might need from data to be declarative and self-describing. Graphs bring relationships forward, but what if database could discover and maintain those links itself from any JSON input? This is the core idea of LMPG, and this is how, out of these conclusions and observations, labeled meta-property graph and RushDB emerged. We wanted to develop something as friendly as MongoDB, so we kept a MongoDB like query language. But then we realized querying only records isn't enough. In real life, we search across everything: records, properties, labels, relationships. And we wanted even to go beyond this and search for values and value ranges themselves. So we made a unified search interface for all of that. JSON became the natural input and querying interface. So you just drop in any data, even messy, and gets it converted into a structured graph by custom BFS algorithm tailored to respect normalization boundaries we just saw. And yes, all of this runs inside real ACID transactions. Under the hood, RushDB stands on top of Neo4j, a true graph native, foundation. In a way, RushDB delivers what GraphQL promised: flexible, structured querying, and everything without resolvers, schemas, and endless boilerplate. Here we can see on my screen how actually some data could look like in RushDB LMPG graph. So we have a user, we have an order, we have a delivery, address, and item. But some of records share some common properties like name or ID, and some of them not. For example, address has city and street and so on. By doing this, we can bring something that has some wonderful side effects. Let's see how it looks in a pure cipher. We have an album, we have a movie, we have a hyper property created, and this is how it works. But creating this manually would take us a lot of time and effort. So RushDB handles it autonomously and on the fly for any incoming data. And this is how unified API looks like. As we wanted to perforate our data from 5 different perspectives, with JSON-like queries, you can ask data, what records do I have in my database by specific criteria? What properties are there with given subset of records? What value and ranges I can ask search with? What labels and relationships can be found? So using the single unified API and unified query object, we can perform search across 5 different perspectives. And it works instantly and dynamically on any incoming data without preparations. Think of faceted search we all wrestling with from time to time on marketplaces. Let's say you're looking for a new dishwasher or kettle. You go to electronics, kitchen appliances, select some brands, and see how filters on the site reconstruct in real time according to subset of items you already filtered. Because of hyperproperties in RushDB and schema guardrails, same faceted search works out of the box. The more you filter, the narrower available values and properties would be. Then this brings unmatched development velocity along with the precision for agentic exploration. So I think enough theory. Let's dive in. First off, let's see how can we describe our data. Let's start with something simple. We have a music album, we have a movie, and let's go and create new project. For doing this, I'll go for projects, create new project. Let's say extended features. Let's say Aura. I'll make it a bit bigger. Aura external DB. And now I can connect my Aura instance or my self-hosted Neo4j instance. Here's my credentials. Please don't use it to scam anyone, me especially. And Yeah, here's the password, and here we go. We created RushDB project, and we already have a token we can use in our applications. Let's go for inputting data, and let's say we want to write something from scratch. Let's name it my media. Let's go to the code and take this JSON data. Oops. Yep. My media. By doing this, we'll create a record. As I mentioned, we have a normalization boundaries. This is a flat record. This is a nested record. This and the other nested record. And these are properties of level 1. So what else we have here? We have a number, we have a string, probably, no, we don't have date time here, but that's not a big deal. Let's import it and see how instantly it's created a graph out of simple data. Let's see how it's connected. So we have my media on top level. We can zoom it in and see the music album, which connected to 2 tracks. So track 1 and track name and so on. And this is how we can ingest any data to RushDB. Behind the scenes, it creates the real data representation in our OR instance. So RushDB could be considered as a powerhouse for your Neo4j workloads. Let's build something more interesting. Let's delete this data. Let's import something bigger. Let's use test dataset. And test dataset is a quite large dataset of company structure. We have a company name, company data, properties here. We have departments, projects, employees, and so on. Let's import it. It will take some time because there are almost 4K records to be ingested instantly out of JSON to our database. Let's update the page. Yes, so we have it. Almost 3K, almost 4K actually records was just ingested. Let's see how it looks. We can see and explore our graph structure here. We have a company. Let's pick it here. Yeah, we have a company. Let's pick departments and projects too. And here we go. We have this nice graph we can explore and navigate with, but that's not the case. That's not the point. We can use the same unified API to search across records, properties, labels, relationships, and even values. Let's see how it works. For example, let's run simple query without any criteria here. It's empty where. We have a match, simple match, which just use our project ID and limits. And we see tasks and something else. Also, with the same payload, we use to fetch properties, and we see how these properties, the first-class citizens we create in MPG approach, these hyper properties are showing us what kind of keys actually describing our data exist in this subset of desired set of records, right? So we can go to basic query and search for some employee, and we see it here. We see that some records match this particular criteria. We have some salary criteria and so on. And we can go even for more complex ones to build simple aggregations by some specific field. So we can see how much projects in active stage and inactive stage we have there. This comes out of any data, and RushDB itself has no idea what should be and what ingested in prior before you actually ingest it. So to show how it works for datasets and for dynamic filtering, which I'm described as, marketplace experience, we have the same data set here. We have tasks, employees, departments, and so on. And if we go, for example, for rating and pick some rating, we'll see that properties would be limited to what we have in only company node. Company node has only this, type of values. Let's say we want to search across some names. Let's go for sports. And we see that for sports, we have only 2 departments. For description, we'll have only 1 description because both of these departments contain only this 1 description. Let's go for something more interesting, and we see projects. Let's filter projects by price. By the way, these properties and these filters are created dynamically based on the same API I showed you previously. Why it's so, cool, and what's the point? Let's say you have an analytical data exploration tool and you want to have a laser focused querying. And to do so, and let's see how labeled meta property graphs looks behind the scenes. So I have a quite large graph here. It even, laggy enough. So we have a properties here. We have some records, and we've just loaded this particular data set. We have data set out of Shopware. Think of Shopify or WooCommerce or whatever, just to perform some graph analytics. We have some orders, we have some customers, we have some categories, addresses, products, and so on. And we use RushDB API. The same goes for Python, and we have the SDK for TypeScript. So we just map our orders, our products, and other stuff all together into API, and we just ingest it to the graph. So for this example, let's say these applications is literally vibe coded and has no idea what actually going on. Let's say we want to perform some graph analytics powered by agents. So let's try something like that. Show me category, or now let's say top performing categories by sales. We want it as a pie chart, right? So now we use agent to perform some exploration. Agent behind the scenes relies on some tools RushDB provides to search properties, to search labels, to build dynamic ontologies like this. So behind the scene ontology, this example for HubSpot data actually, but the idea is the same. We have a HubSpot data ingested the same way into graph instantly out of JSON, and then using these RushDB APIs, we can build dynamic ontologies. These ontologies goes to a system prompt, and based on these ontologies, our agent is able to perform some analysis like that. Let's go for some kind of queries I've performed previously, like top selling categories, sales amount, revenue by category. It's quite nice way to perform something. So agent behind the scenes looks for what we called category, but actually in database it called SW categories. So we use some kind of synonyms for performing these analytics. And out of this, only having a data, we let agents to investigate, to explore what records we have, what relationships they have, what properties they have. And what's more important, we have a laser focused values and precision, because we have a same way to find out what values available amongst some desired data set. For example, we're not guessing what actual data and what actual ranges exist in orders amount, because we are absolutely certain that we have a certain range for for this kind of property, and that's how RushDB works behind the scenes. Let's perform some more interesting queries here. Let's go for deep aggregations. As we ingest some JSON, why couldn't we ask our database with JSON? So by performing this query, we can literally reconstruct our original structure back to what we wanted. So every developer building graphs and building with graphs now can use it just to skip routine, to skip mapping data to controllers to services, because all you need is just GraphQL-like experience, data properly mapped, and even if it's not, you can still build something out of graphs. So what we're doing actually with RushDB, let's get back to our slides. RushDB actually democratizes graphs for broader developers and data enthusiasts by removing taxation, of mindset shifting, letting any data become intelligent. LMPG is built on top of Neo4j, so it automating schema creation and enriching the LPG model with self-awareness. It literally what happens when you make Neo4j so reflexive. Think of RushDB as a cognitive layer that sits on top of Neo4j powerful graph engine, making it accessible for developers who want to instant productivity and also for AI agents that need self-describing data structures. So that's pretty much of it. It's my pleasure to be here, and thank you. Have questions here? Oh, thank you guys. Thank you. Yeah, actually, I'm not yet delivered to production two-dimensional representation, which I showed you on demo, because two-dimensional helps you to see how properties. I'll show you shortly, just in a moment, how properties looks like in this approach. Let's go for this one. I need my screen. Let's say we want to see some orders by some specific criteria. Property filters would follow. Yeah, nice. Let's fit it. So this is the graph without properties shown. Let's see, we want to have some specific ID for our order. And this ID will take some time to render. Yeah, we have one order, right? By some specific criteria. But when we show properties here, we see how it looks like behind the scenes. So we have some properties in this order. This order contains all necessary, all own properties as classical LPG. But at the same time, it connected to hyperproperties with type and name and having all of this as metadata guardrails, which help us to identify subsets dynamically for any incoming data. So we can push, JSON, CSVs, we can feed it to Neo4j graph and still have data autonomously interconnected to each other by sharing some properties like order number, which is number, or state, which is string, probably delivered or not delivered or something like that, currency code, address ID, and so on, amount, also number, yes. And as you see, RushDB also normalizes data. Oh, what's happened here? I'm not sure. Let's make it a bit, yeah, here we go. So we can see that records we've ingested get, let's go for, let's say, task. They have autonomously inferred its own types. So for created at, we have date time created natively in RushDB. So if you feed something ISO 8601 date time, you'll see the data. You'll see the type of this data shown like this. So this is created at, this is a date time. And with given date time ranges, I can perform something like, let's say, we're looking for employee born after, let's look for some Zoomers, the hot topic. Yeah, now we can see all guys in our company born after this particular date. And this is how it helps you to build, filters dynamically out of any data. And what's interesting here is that even if you're more about data and if you're working with data, you also have to make some applications to represent results of your work to, C-level, to managers, to partners, and so on. And with this instrument, you can skip all boring stuff that we're used to follow, to map our data to some materialized view, to map it to some controller, to map it to some service, to deploy it somewhere as a single separate backend service, and then to wipe code or code front end for it. Now we can skip all of this stuff and just use Neo4j and RushDB interconnected to build seamless experiences out of graphs instantly. So think of Notion meets MongoDB meets Neo4j, and they're all go to bar and take 3 beer, something like that. Yeah, sorry, my jokes are still not so jokey, but thank you. Yep. Thank you. Any Rust-based client out there will be. Is the chat interface provided with the database? We are considering to add this, but we want to keep RushDB as a single, simple data foundation, the boring infrastructure startup, I would say. So probably we'll run it as a separate plugin or some tool or marketplace of tools that can be built around, because what RushDB gives you is the ability to build applications instantly out of graph data, and it's worth to build chat interfaces on top of it too. Is it cloud native? Can it deploy it in our Kubernetes? Yes, of course. It's open source. You can find out it in our documentation how we can run it. It has already Docker container published in Docker Hub. And is there support for CQRS protocol? Not yet, but if you be so kind to create an issue in our GitHub, there would be support. Thank you. Thank you, everyone. See ya. Bye.